Okay, today we finished up our discussion of energy and flow in pipes. And let me just hit on two key topics, I guess, that we covered today. First is about the performance of pumps. And the head that's delivered by a pump, H sub P, is itself a function of the flow rate Q. And that's something that's defined by the way the pump is constructed, the way it's designed, and is usually reported by the manufacturer. But we have a second relationship, which is from the energy equation. And the energy equation also relates the head delivered by the pump as a function of Q. Usually this looks something like HP goes as Q squared. So thinking about this graphically, if we have Q on the horizontal axis and the pump energy added on the vertical axis, the energy equation, I'll put in blue, has some kind of quadratic form. Energy equation. The pump performance, which I'll put in red, has some diminishing return. And so the operating point of the system is the intersection of these two curves, and so that's going to be the solution. So that's the first key thing that we covered today. The second is parallel networks. And in parallel networks, the key result is if we have a pipe that branches, I'll just do it with 2 for this example, then the head loss along flow route A has to equal the head loss along flow route B. So if I think about the head loss going along A, the head loss along A has to equal the head loss along B. And what happens is the velocity along A and the velocity along B will adjust in order to make that balance happen. Second relationship is that VA times the area of A plus VB times the area of B has to equal Q, where Q is the total flow entering and exiting this junction. So together that gives us two equations, the first being the equivalency of the head loss, the second being the equivalency of or mass conservation, from which you can solve for the two velocities or the ratio of the velocities. If there were more than two branches, essentially the relationship becomes that head loss along each branch has to be the same. So if you have more, it'd be head loss along A equals head loss along B, head loss along C, head loss along D, etc., etc. So every branch has to have the same head loss, and that's because the energy loss going from upstream to downstream has to be independent of the path taken, since the pressure drop or the elevation drop is the same.